So when we're calculating this question, the first thing we need to do is look at basically the standard normal distribution. So in the Jenny throws a javelin, which is non-distributed, means 42. So let's get it. And standard deviation is 5. But then we standardize it. For J to be less than 40, we end up standardizing it into a standard normal distribution, which is x minus x bar over sigma. This is the formula which changes 40 and the mean of 42 into the standard normal distribution using the z tables. So when we substitute it in, we get a z value from here, which is negative 0.4. And just like that normal distribution, we actually have the standardized form. So this is the original population normal. Now, if I draw the standardized form of this, we're basically saying the standard normal distribution will have a mean of 0. And we know that negative 0.4 would lie on the left-hand side over here, like that. So, yeah, so the probability, now this is going to be z, this is the z-axis, whereas this one here is the j-axis in this case, j. And this probability, by the way, is the same as this probability over here. So once we calculate this, we can get that. Now using the z tables, all I need to locate is 0.4 and then get the corresponding probability from there. If I go into the z table and I look for 0.4, preferably negative 0.4, which they actually have there, I can see negative 0.40, so 0.4 on the side and 0.00, so negative 0.40 looks like it's exactly there, which means that that area is going to be 0.3446 or 34.46% on there. I'll go back to the question. We basically have that probability now, which is 34.46%. So find the probability that distance Jenny throws the javelin is less than 40 is going to be 34.46% on there. All right. So that's what we would put in for A. Let's have a look at B now. For B, so Jenny enters a javelin competition. To qualify for the final, she has 3 attempts to throw the javelin distance of more than 40 meters. So we know the probability that it's less than 40 meters is going to be 0.3, which means that the corresponding area on the opposite end is going to be 100% minus 34.46%. And that comes to, it's 100 minus 34.46, which is 65.54%. All right. So, given that Jenny qualified for the final and that throws of the javelin are independent, we're given that Jenny entered the javelin competition. To qualify for the final, she has 3 attempts to throw the javelin a distance of more than 40 meters. So this is where we're saying it's more than 40 meters, so greater than 40, which would be that probability over there. Once she has qualified, she does not use any of the remaining attempts. Okay. So she has to get that 3 times. Given that Jenny qualified for the final, and that the throws of the javelin are independent, which means like the probability of A times the probability of B is the probability of A and B occurring at the same time. Find the probability that she qualified for the final on her 3rd throw with a distance greater than 45 meters. Find the probability that she qualified for the final on her 3rd throw with a distance greater than 45. So we actually want to find the probability that j is greater than 45, but that's on one throw. So the next question is, what is the first two throws going to be? So we got throw 1 and we got throw 2. What would each of these probabilities be? We know that this one here is going to be greater than 45. So in order to qualify, she has to have more than 40 meters, right? So we can assume that she gets more than 40 on the first two throws and then gets more than 45 on the third throw. And it says with a distance of greater than 40. Are they talking about the average of the three throws? Or are they talking about the third throw only being greater than 45? The third one only. All right. Okay. If the first throw and the second throw is less than 40, then she has 3 attempts to throw the other more than 40. So we're saying that it's actually going to be less than 40. You're right. So this is actually going to be less than 40 because she didn't get through. And then finally that. So actually we're going to have 0.3446 as a probability on the first throw, 0.3446 as a probability on the second throw. And now we need to calculate the probability that she gets greater than 45, which means that we've got to recreate the z value there, x minus x bar over sigma. And that's 45 minus the mean, by the way, this is x bar, which is 42, over 5, which comes to 3 over 5, which is 0.6. And the probability that z is greater than 0.6 basically would be in that region there. That's the percentage that we want to find. So we go back to our z table, and now we're going to find the 0.6. Let's go to 0.6. This is in the opposite region, so greater than negative 0.6, so 0.6. 0.7257. 0.7257. Alright, let's double check that. Greater than 0.6. 0.6 gets me a probability of 0.7257. 0.7257. Let's write that down. So probability that z is greater than that, 0.7257. So there's a 72.57% chance that that would take place if it's greater than 0.6. Now, that doesn't really make sense because that would be actually in the other way, because this is 0. That would have to be less than 50%. So it would be probably 1 minus this. And that would be 1 minus 72.5%. So 1 minus 72.51. Yes. Which would be 27.43. Right? So 27.43%. And that sounds more like a 27.43%. So this is going to be 0.2743. And that's the probability that that would take place. And if I multiply these probabilities, that should give me the probability that she qualifies on the third throw with that. So she doesn't qualify with 0.3446 times 0.3446 times 0.2743. And that's equal to 0.0324 Okay. So there's a 3.26% chance that she would qualify for the final. It's quite a slim chance that, eh? 3.26. So now that we have this 3.26, we have to calculate the probability that she qualifies. And she does not qualify with this probability. And if she throws all three throws false, then she will have 1 minus that probability. So the probability that she actually qualifies is going to be this over here, which is 0.9590, which is 1 minus the probability that she does not qualify at all. Which means she gets less than 40, less than 40, less than 40 with a certain percentage, but that's going to be quite a small amount. And we take 1 minus that. So this is going to be, we'll be using a conditional probability. And we're going to divide this now by 95.9%. Yeah, so the formula for conditional probability is what we need to use here. And to use the conditional formula probability, we're saying that the probability that A happens given B happens is actually the probability that A and B happens divided by the probability of B happening. And if they're independent, then it's probability of A times the probability of B divided by the probability of B. That makes sense. And so that would mean that in this case here, the probability that she qualifies for the final on her third throw, given that she's qualified, so we're given that she has qualified, we just want to know what's the probability it was on the third throw. So we have to then calculate that part there. The probability on the third throw, remember, is given by probability of failing, and then passing, you could say. And that's this one here, 0.0326. The probability that she qualifies is 1 minus the probability that she fails 3 times. You can also look at it in terms of a tree diagram. So she's got 3 throws. The first throw she can either fail or pass. The next one can fail or pass. And then likewise after that, fail or pass, fail or pass. So the probability that she fails, as you can see, is going to be that. The probability she passes is actually all of those together. Then she can also pass along the way with all of those. So what's guaranteeing us that she will not at all would be 1 minus that. So we've got to say 1 minus the probability that she fails 3 times, which is 1 minus the probability of, which is this part here. And that's us the 95.9% space. So we're actually narrowing down the sample space in the tree diagram. So what we're actually doing over here is after drawing that tree diagram, so we've got these branches. And we're saying that that's going to be fail, fail, and fail to qualify. And the rest of it, that's the 95.9% that she passes. And from these options, we want to know what is the probability that she qualifies on her third throw, which means she will have failed, and then passed after that. Okay, so what is the probability that she qualified on her third throw. So that is 0.0326 or 3.26%. And that line is a probability of passing, given that she has definitely qualified. What's the chances that? So we're not actually finding the probability that she qualifies. We're finding the probability that she qualifies a certain way, knowing that she's qualified already. Basically.